Graph some derivatives here. Let's see if I can maybe make this a little darker so we might be able to see our contrast. Maybe I could change the contrast here. No, that's not working. Saturation. It's kind of hard to see the grid. Okay, we'll give it a shot here. Looks like this line is going down at 2 for 1, and it's going down all of this time for those last three. So if these squares are 1, 2, 3, and 1, 2, 3, they should put some scaling on here. Then we should be at minus 2. It's going down 2 from here to here. It's a sharp bend, so that means the slope quickly, instantly changes from minus 2 to 0. And it stays a slope of 0 up until minus 1, where there's a sharp bend, and so the slope quickly changes from 0 to, that looks like a slope of plus 1. And it stays the slope of plus 1 until we get to 1. Sharp bend, and it goes back to 0 for 1 unit. Then it looks like it goes to a slope of 2 for 1 unit. Oops. And then it goes to minus 2 for 2 units. Slope is minus 2 from there to there. Then it goes quickly back to slope of 0. Okay, that was the first one. Now, if this is 1, 2, 3, and 1, 2, 3 for the grid, and the slope here is almost 0, but it's on the positive side. And it finally gets to a slope of 1, which looks like this. Looks like that's about what it is in this part right here. So right around there, it's at 1, and that looks like it's the steepest positive it gets. Up here, the slope is 0. Here, the slope is negative 1, and that's about as steep downhill as it gets. And then it heads back towards 0, but it's still negative, so it's on the negative side and close to 0, close to 0. So it must go from here down. Oh, right there, the slope is 0. And then it comes down, and that's as steep as it gets, and then it gets less steep, and it gets less steep. That's assuming the units are 1 and 1, 2, 3, 4, 5. Okay, this one. This looks like a parabola, clear to there. Parabolas have slopes that are lines. Right there, it's 0 slope. Here it looks like it's about plus 2, just following this line. That looks like about the tangent line. So it's plus 2, and if that's a line, then it's probably down here and probably down here, which makes it negative 4 right there. Is that about right? Down 4 for 1. That look like about the slope there? I think so. So because parabolas have a slope function that's linear, we get that. This is a slope of 2, always 2, constantly 2. And then, and this kind of transitions there, so this is not a square corner, it's kind of roundish there. It transitions into it. Here, though, it changes quickly. A corner, a cusp, as they're called. Cusp. And so at 0, it's non-differentiable. And it looks like it goes from a slope of 2 to a slope of -3. And so for a while it stays -3, and then it turns into a parabola. It looks like a parabola through this part, where this is slope of maybe -2. So it's kind of working its way up to -2 and 0 here. Oh, 0, -2, 0, +2. So we have something that kind of looks like this. Then there's a sharp turn. And it all of a sudden now has a slope of about a half. Up 1 for 2, up 1 for 2, slope of a half. Okay, we now learned in class that somehow cosine becomes sine and sine becomes cosine, but they're not exactly that. Slope is 0. Slope is 0. Slope is 0. And slope is 0, and slope is 0, and slope is 0. Now, right in the middle, that looks like a slope of maybe down 3 for 1, 2 or 3, something like that. -2 or 3. I'll put it at -3. So this slope must be +3, and -3, and +3, and -3, and +3 there. Plus slope there. Down. These are curves, not sharp corners. Now this is not quite the sine graph. The sine graph would go this way. And this goes the other way. So this one goes from a cosine to a negative sine. Times some stuff in here. There's some multipliers to make these work. And without units on here, it's really hard to tell exactly what that number would be, but something like that. Looks like this one might be 2 units if it's each square is a unit. So this might be -2, -3, or something like that. Okay? That's the last one, 9, I think.